Describe the transformations of the following functions. Now remember, if something is changing the inside, that's causing a horizontal change. Horizontal. Okay, now it's being multiplied times x. So this is going to be a horizontal. And remember, x is a liar. So you think, oh, because it's smaller, it must be getting compressed. But it's opposite. It's a horizontal expansion or stretch. Stretch. Now here's the key. By a factor of not 1/3, which a lot of you guys put on your quiz, I didn't mark you down for it, by whatever this is here. Basically the reciprocal of that fraction by a factor of 3. Okay? By a factor of 3. Okay? And then this is outside, so that's causing a vertical. Remember, outside is vertical, inside is horizontal. And if it's outside, it's true to itself. Okay, it's telling the truth. And if it's minus, it's going down. Vertical, shift, down, 7 units. Okay. Now this one, let's start with the negatives. Negative is outside. So again, that's vertical because it's outside. And it's a vertical. Negatives, what do? They reflect. Okay, it's a vertical reflection. Okay. Over which axis? If it's turning vertically, that means it's kind of spinning like this way. Okay, so that means it's going around the x-axis. So we would say over the x-axis. Okay, and then on the inside, that's a horizontal, remember. And remember, x is lying to you, and that means it's not going in the negative direction to the left. It's going in the positive, it's not going in the positive direction to the right. It's going to the left. 4. Horizontal left, 4 units. Okay. All right, create a quadratic function with the following transformations based on the parent function. So here's our parent function. We need to vertically stretch it by a factor of 3. Remember, vertical, where do I put the number? Outside. Okay, so stretch, remember if it's outside, the bigger the number, the more it'll stretch. Okay, so let's do this kind of one step at a time. Now f of x, remember that's the original equation, so we do not want to write f of x, we just put a new letter. You can use the same variable, that's fine. Okay, that's the first thing. Reflection over the x-axis. Remember that's just like up here, that's a vertical flip, so that's outside, so make it -3. Okay, then horizontal compression by a factor of 1/4. Okay, so we want it to be compression. Okay, so that means it's going to be inside. And now it's saying it's going to compress, right? Compress. This number should be bigger, because remember we're inside. Okay, bigger numbers inside cause it to compress. And that's why it's 1/4, because remember, like I said up here, it's the reciprocal of that. Okay, this is a stretch, so it's stretching by a factor of 3. But now when the number is bigger, the compression is by a factor of 1/4. It's like the reverse. Okay, the only time it's the same is this would be a vertical stretch by a factor of 3. It's true to you, but you always, again, switch it if it's in the inside. Okay, now there's no movement left and right, so that we can close the parentheses. And remember, it's a quadratic, so we got to put squared. And the last one is vertical translation up. So it's going to go up, so we're going to add 4 to make it go up 4 units. Okay? And some of you guys, well, can we simplify this to make it -12x squared? That doesn't work because we'd have to square the 4 first, so just leave it like this. Okay? Before you actually multiply the 3. Okay, so for number 6, so what we've got is this Maria. She created the following linear function, this line right here, after hearing her friend Miriam describe it to her based on the parent function. So again, if it's just equal to x, that's a linear function, just a straight line. We'd have to decide if she's correct or incorrect and be able to justify your answer. So Miriam stated the following transformations occurred, but not necessarily in this order. Okay, so it says a horizontal stretch by a factor of 4. Okay, so what we want to do is create the function. Okay, so this is the parent function. Okay, and so let's start with the horizontal stretch. Horizontal, remember that's inside. Okay, so we can, just so for memory's sake, we'll do parentheses, which isn't always necessary. Okay, a stretch, right? We want it to stretch. Now inside, remember, is always everything's opposite. So if we're stretching, we don't want it to be a bigger number. We want it to be smaller, and by a factor of 4. So we're going to do 1/4. Okay. And now a vertical translation, 1 down. Okay, so that means outside, we want it to go down 1. And the last one, a reflection over x. Okay, remember if it's over x, that's a vertical movement. So that means we want that negative to be outside. And remember, this is a new function, so don't write f of x. We want to write g of x. Now remember, it says to justify. Okay, that's a key word there, justify. So this is what I want to see. I want to see the new function, and make sure you state what the action one should be. Okay, is this actually that function? Well, first of all, the y-intercept, well actually, let's simplify this. Okay, we don't need parentheses because there's no squared or cubed out here. So it's just minus 1/4 x minus 1. Well, first of all, we can already see that she's incorrect, right? Because the y-intercept there is +1 and the y-intercept here is -1. She got the slope right, down 1, right 4. Okay, but then she got this intercept wrong. So we can just say the y-intercept is incorrect, or you can say, actually I shouldn't say or, I just said that out loud. Okay, or you can say that she, wow, thinking out loud, she did not, she shift down, or she went up. Okay, somehow justify it. So I'm not saying you have to have all this information here, but I wanted some kind of explanation of why did, or what did she do wrong. Okay, and then make sure you state what the actual function should be. That's the key part. This, and then an explanation. Okay. All right, now we're moving on to factoring. Okay, so letter A. Well, first I recognize right away that that's a perfect square. So I can use the shortcut. Okay, all I do is the square root of the first term. That is the first term that goes there and there. So that'll be 4x and 4x, and then square root the second term. And now that will be 15 and 15. And remember, if it's perfect squares, we do plus in one and minus in the other. Now just remember though, this only works if that's a negative in the middle. Because if this were to be plus, this would not work. Okay, so that would not work. All right, so now this next one, you do a couple things. Well, first, I'm just going to show you the quick way. Again, if it's just 1 in front of this quadratic expression, I can just put that d and d there. Or if it was x squared, I could put x and x. And then I can just think in my head, what two numbers multiply to negative 56, but then also add up to minus 1? Well, the first two numbers that come to mind are 8 and 7. And I need that to be negative, so that means my bigger number should be negative 8. Or you guys can do the x. Okay, remember the a times c goes up here. A is 1 times negative 56 minus 56. And then your b goes on the bottom, so minus 1. And I do the same thing. I find those two numbers. Okay, negative 8 times 7 equals the number on the top. And negative 8 plus 7 equals the number on the bottom. So those are the numbers I can put there. Okay, but just remember, when we get to this problem, that's different. We can't do that quick shortcut. We've got to take a couple extra steps. But you can do this a quick way too. I'll show you that in a minute. Okay, so now this one, letter C, if you notice, we've got f cubed, f squared, f to the 4th. Well, and also we have 25, 5, and 10. These all have common factors. So what we want to do is first find the GCF. Let's factor out a GCF. So what I'm going to do is divide. I know that all of those I can divide by 10. I'm sorry, not 10, 5. And the greatest common factor between the f variables would be 2f's, so f squared, because they all have at least f squared within them. Okay, so now that becomes my GCF, which I put right in the front. Okay, and now I divide it out. So 25 divided by 5, that's 5. And then f to the 3 divided by f2, that's just f. Okay, then let's see, negative 5 divided by 5, that's minus 1. Okay, then f squared divided by s squared, well that cancels out, that's 1. So this next one is just minus 1. Okay, then 10 divided by 5 is 2. And then f to the 4th over 2, f to the 2 is f squared. Okay, so that will be 2f squared. Okay, so what I want to do first is that if you notice I have f squared, I have f, and I have just a constant here. So I want to rearrange this. So we're going to do 5f squared, 2f squared. Let's put it in the right order. Okay, and now I want to see if I can factor this. Okay, so I'm going to try to do it the quick way. So 5f squared. I want to round up my binomials. Okay, so I know I have to get 2f squared. So I do 2f times f. That gives me 2f squared. And then I have to, and then what numbers multiplied to 1? Well, there's only one combination for that. So 1 and 1. So I'm not going to have to kind of play around here because this has to be negative, so that means one of these has to be negative. So let's just say that's negative and this is positive. And now I'm kind of looking at it. I'm noticing that if I multiply 2 times f, or sorry, 2f times 1, and then 1f, and then 1 times f, there's really nothing that's ever going to add up to 5. So what this means is that this is not factorable. So in other words, you would just stop here. If you can't factor it, that's it. But you want to try, see if you can factor that. Another way you can do it is, let's say I get there, and I do first a times c, so 2 times minus 1, minus 2, then the 5 goes on the bottom, okay, and then I try to find what two numbers were multiplied in minus 2, but then add up to 5. Well, the only numbers that multiply to 2 is 2 and 1, and so I can't add those up to get to 5, so this is not factorable, so that is my simplified expression. So all I had to do was basically just do GCF, but you want to try. Okay, so now this one. All right, well now the leading coefficient is not 1 anymore, so this I'm going to have to do some extra steps. Well, first I'm going to show you the shortcut. Okay, I know that's 2y squared, so that means 2y times y. Okay, and then to get 15, I only know one combination, well 2 actually. It's either 1 times 15 or 3 times 5. Okay, now I'm thinking if I put 1 and 15 here, that probably won't give me the 1 in the middle that I need. So I'm going to try the 3 and the 5. So I have to think to myself, where would I put those to make that work? Well, if I put, it's always better to do this in pencil so you can just erase it, right? Okay, so let's say I put 5 there, 3 here. Well, then 2 times 5 is 10, and 3 times 1 is 3. So 10 and 3, I can't make 1, so I'm going to switch them. And put 3 here and 5 here. 2 times 3 is 6, and then 5 times 1 is 5. 6 and 5, I can make 1. Okay, but one of them has to be negative. Okay, and it has to end up being positive 1, so that means the bigger number, the 6, I want it to be positive, so 3 times 2 is 6, and then minus 5. And there it is. Okay, now I'm going to show you the other way with the x in the box. Okay, so first you do the x, 2 times the last number. I'm sorry, a times c, which is minus 30, and then you put your b on the bottom. What two numbers will multiply to negative 30 but then add up to 1? Well, that's 6 and 5, and that means the 5 has to be minus. Okay, so now I'm going to set up the box. And remember, the first term goes in the first box. The last term goes in the last box, and then I put 6 here. And then the negative 5 goes here, but don't forget to include x. Okay, so now I know that I have to do the same thing. 2y times y gives me 2y squared, but the question is, where's the 2 go? On the top or the side? Okay, well, I just take one row or column here, and oops, sorry, that should be a y, not an x, and find the GCF between 2y squared and 6y. Okay, well, the biggest number I can divide is 2 here. and then they both have y in common. So the 2y goes on top, and that means y goes here. So 2y times 3 gives me 6y, and then y times minus 5 gives me my factors, and boom, there they are again. Same thing, just a different way. Okay? Okay, so now this one, well, that's not a perfect square, that's not a perfect square, so I can't just do that quick method like this shortcut. Okay? So, but I do notice that I can divide 3 into both of these. So I'll do a GCF. So divide out 3. 4 divided by 3 is 16. Then 3 divided by 3 is 1, so that'll just be c squared. But now I notice that's a perfect square. That's a perfect square because it's just 1. Okay, so what I'll do is we're going to, first of all, don't forget to leave your GCF out here. Okay, same thing up here. Don't forget the GCF once you take it out. Make sure you put it back down there. Okay, it doesn't disappear. Okay, so what I'm going to do is take the square root of 16, which is 4. That's the first term. Okay, and then the square root of c squared, which is c. That's the second term. And then it's plus and minus. And if you notice, the variable goes second this time because it went second up here. Okay, so that's your second page.